Moving on to configuration. Um, I'm going to go through this part quick because it's pretty much basic what we have covered so far. There are three different kinds of configuration for um, a transistor. There's not much difference between the three except for, and the easy way to identify is that common base would mean your base over here is connected to both collectors and emitter, and your base is basically connected to the ground. That's what it means, common base. Similarly, if you look at over here, again, your base is connected to both emitter and collector, and your base is connected to the ground. That's what it means. The symbol for this is the symbol for the um, transistor. So again, remember, current flows from positive to negative terminal, right? Positive to negative terminal. That's the conventional current flow. Conventional current flow. And that helps us identify whether this transistor is a PNP or an NP. So if you look at this graphics right here, okay, because the direction of the current, this arrow is downward, that means this has to be P, this has to be N, and this has to be P. Okay, because like I said, the current always flows from positive to negative terminal. So this has to be positive and this has to be negative, positive to negative. Okay, so this means this is a PNP type resistor. Many years ago, folks, when these transistors, they came out back in 1947 and all that, the books were written in different kind of languages like German, Russian, and okay, so they basically came up with this kind of representation. You don't need any kind of, you can be reading any electrical engineering book that was published or written in some kind other foreign language. Looking at it, you should be able to find out what kind of transistor it is. Again, everything is labeled here because the direction flow is something like this. So we know current always travels from positive to negative, and if this is P, this is N, then this is a NPN transistor, NPN transistor. Okay, so it's good to know and all that. And if you look at over here, say over here, you got, if I ask you guys, what is the current that is flowing, going in and going out? Is that holes or electrons? What would your answer be? Are holes taking part in conduction here, or electrons taking part in conduction here? What does this P means? This P means you have a P-type material here, right? And P-type have a lot of, majority carriers are holes. So it's the holes that take part in conduction, right? What's happening here? You got N here, correct? You got N here. So you have N here. N has what? A lot of electrons, okay? So we have the electrons taking part in the conduction. Okay, so it's very easy to recognize with only this kind of information. Okay, whether what kind of transistor it is, how the electron is going to flow, or how the holes are going to flow, what is going to be the direction of the current. Okay, so common base amplifier, this is something that is going to be a part of the data sheet. Okay, data sheet, it will be given when you buy a component or a transistor, it will be given. So what does this tells you? The input characteristics of the transistor. This curve shows the relationship between the input current to the input voltage for 3 output voltages. Okay, all right. So this is going to be input side, and this is always going to be the output side. Okay. Similarly, again, you got this input side right here, and then you got the output side. Okay. In the input side, the voltage that is associated is between these two terminals, right? V and BE, correct? The base and the emitter. On the output side, it is VCB, right? Collector terminal and the beta terminal. What is the current in the input side here, folks. The current is IE, right? In the input side. And in the output side, the current is IC. Okay. So when you are looking at the input characteristics, you are basically seeing it VBE versus IE. And the output side, you are looking at the output characteristic. You are looking at the graph, which basically tells you VCB versus IC. So let's look at right here. This basically tells you, okay, you got VBE here. That's your input voltage right here. You got your input current over here, which is IE. And at different VCB, at 1 volt, you have this curve. Okay, this is going to be given. VCB 10 volt, fixed 10 volt. This is the, okay. So at VCB 10 volt, say if you are over here, okay, so your IE is 7 milliamps, and then your VBE is going to be 0.7. Okay. So this part of information is useful for now. Is for today's lecture, just know that you know how you can read these numbers. And this is the output characteristic. Remember, in a common base amplifier, the output current is the IC, right? That's the output current, and the VCB was the output voltage. So again, here, this is part of the data sheet. It will be given to given to you, data sheet. This region that you see over here, as it says saturation region, okay? In a saturation region, okay, saturation region, can you tell me what is VCB here? In this region right here, what is VCB on the x-axis? 0. If you look at the x-axis, okay, and if you look at saturation region, these values are 0 and negative, right? So VCB is going to be 0 volts. What about the current IC in this green region? The current is going to be maximum, okay? Current is going to be some value. It's going to be some maximum ID value. So when you have a current that is maximum, that means your transistor is working in a saturation region, and that means it's on. It's on. It's working as a switch and it's on, okay? Now say if your transistor is working in this region right here, this region is known as the cutoff region, okay? In a cutoff region, if I ask you what is VCB? Yes, folks, and what is IC? So VCB here is some maximum value here, some maximum value. But IC is what? IC is what here? Yes, guys. What is IC? Is it 0? Yeah, IC is 0 amps here. 0 amps here. So what does that mean? If you have no current, that means you are in a reverse bias region or cutoff region. So your transistor is working as a switch where it is currently set to off position. Okay. Anything other than that is considered as active region, which is this region right here. When you have your transistor working in a saturation region, that is when it's working as an amplifier. Okay, so I think I'm going to stop here. But tomorrow, Thursday, is going to be it's going to be a very interesting uh, class, and where we are going to learn, okay, we do understand that transistor can work as a switch as an on position, can also work as a switch in an off position, can also work as an amplifier, having these two regions. Okay, but how do we make them work in these regions? If the Q point, like the operating point, is over here, so it's working as an amplifier. But if I want to move this Q point to over here, right? So that means it is in the saturation region, so it's working as an on switch. Or even within the active region, I want to change my Q point from here to somewhere over here. How can I do that? That's what we are going to learn, and that's where you understand how your transistor, how you can use it to work it as a switch or as an amplifier. Okay, so I think I'm going to stop here. So this is the same thing, cutoff region, saturation region that we just studied, and then the active region is basically where it works as an amplifier.